Okay, so here we have some simple stoichiometry problems. And by simple, I mean they're only going to require a mole ratio, okay? They are all different too, so I'm going to talk about some of their differences as we go through them. But what we're talking about here, the first one, 13.6 moles of iron sulfide will react with how many moles of oxygen, okay? So if we look at our molar map, we've got moles of iron oxide, and the question is asking for moles of something different, of oxygen in this case, okay? So between those two is a mole ratio. That's the step that we need to convert between the two. Please use this. If stoichiometry is challenging for you, and it probably will be more in a virtual setting, please, please, please use this. Where are you starting? We're starting in moles. What are you trying to find? Well, we're trying to find moles, but moles of something else. So we have to switch over from the maroon side to the gold side, okay? So here, 13.6 moles of iron sulfide, that gives us our starting point. You're always going to start with that 13.6, whatever that given value is of FeS2, okay? And then, I know I do a grid. This is the same thing as doing 13.6 moles and then doing multiplication with a fraction next to it. So I know that that's a little bit different depending on who your teacher is. But I do a grid, okay? So here, 13.6 moles of FeS2. Well, there's a ratio between FeS2 and oxygen in this equation, and that ratio is 4 to 11. 4 moles of this for every 11 moles of this, okay? Where do I want to put 4 moles of FeS2? Well, I want FeS2 to cancel. It's on the top here. It needs to be on the bottom here in order to cancel. So 4 moles of FeS2 for every 11 moles of O2. So my FeS2 will cancel out, and then I can punch this into my calculator. Okay, so 13.6 times 11 divided by 4, and we're going to get 37.4. 37.4, and my unit, moles of oxygen. Now, real quick note on sig figs, these are infinite, 4 and 11, okay? This is an exact ratio of those substances in this chemical reaction, okay, if this was a perfect reaction. So 4 to 11, those are infinite. This only had 3 sig figs, so I end up with 3 sig figs in my answer, okay? Now, the next one's different for a couple of reasons. One, my units are different. I've got liters now. If 2.4 liters of oxygen react, how many liters of SO2 will be produced, okay? So 2.4 liters of oxygen, how many liters of SO2 are going to be produced? Again, we can go back to this molar map, and we're working in STP. Please make that assumption. I have a very narrow whiteboard here. I would have written at STP, but we're just trying to get through things a little bit quickly, okay? So at STP, we're at volume at STP of oxygen, and I want to know a volume of something else, SO2, being produced, okay? Now the other difference is now I'm working with a reactant and a product. So I've got one thing before the arrow, one thing after the arrow. What you need to remember is that the mole ratio, it doesn't matter if we're talking about one of them as a reactant, one of them as a product, or if we're talking about both reactants, like up here, or down here if we're talking about both products. The mole ratio is still these numbers in our chemical equation. We're just kind of ignoring the other substances that are not part of the problem. So here, my starting point is 2.4 liters of oxygen. Whatever you're given in the problems, your start, okay? I'm going to go ahead and put my grid. Alternatively, you can do a multiplication sign and a line here, okay? Now, I want liters of oxygen, liters of SO2. Again, the connection between those two is a mole ratio, and that only works because they're both gases, okay? So these numbers up here, this is my mole ratio, 11 moles of oxygen for every 8 moles of SO2. Or, because they're gases, I can just change the units. So when we use the mole ratio down at the bottom of that molar map, it's connecting two volumes. The units you want to use are liters, the volume unit, okay? So this is the same as saying 11 liters of oxygen will react to produce 8 liters of SO2. So I want my oxygen on the bottom to cancel. I want my SO2 on the top because that's what I'm trying to find, okay? So 11 liters of oxygen will produce 8 liters of SO2. So my liters of oxygen cancel out, and now I can do my calculation. 2.4 times 8 divided by 11. We get a big number here, lots of digits. Hopefully you can tell me already that it's going to have two significant figures. So we're at 1.7 liters of SO2. 1.7 liters. Okay. All right, the last one down here, 7.2 times 10 to the 23rd formula units of Fe2O3 are produced when how many molecules of SO2 are formed? Okay, so difference here, now we're in particle units. Okay, so we're working at the top of the molar map, particles to particles. Again, mole ratio. But because it is connecting particles, our units are going to be particles. Okay, either molecules, atoms, or formula units. Okay, so when we're working, start with what we're given, 7.2 times 10 to the 23rd formula units Fe2O3. Now I need to find my ratio, Fe2O3 to SO2. Well, they're both on the product side. That's okay, still a ratio, 2 to 8. We can say 2 moles for every 8 moles, or we can say 2 formula units, which is a particle, will be produced every time 8 molecules, which is a particle, of SO2 are produced. So 2 formula units for every 8 molecules of SO2. Okay? Well, hopefully we can already tell we want the 2 formula units of Fe2O3 on the bottom, because that's what I'm trying to cancel. 8 molecules of SO2 on the top. So 2 formula units Fe2O3 for every 8 molecules of SO2. So my formula units cancel out. Now I'm ready for my calculation. Okay, and you're going to get 2.88 times 10 to the 24th. Again, infinite sig figs here. That one only has 2 sig figs. So I'm going to have 2.9 times 10 to the 24th molecules of SO2. So those are our most simple stoichiometry problems, and we'll see a couple more videos coming up to make it more complicated.